Hey guys, it's Dustin here from DG's Pro Tech in Listowel, Ontario. Well, lots about turbos going on these days, so we thought we'd do a video on VGT turbocharging and talk all about the stock turbos before you get into the performance stuff. I dug through my core boxes and I pulled out a couple different applications here to show you some stock turbocharging in different engineering designs. Now, you're gonna see a lot of power stroke stuff because that's what I had for cores to show you. In the late 90s, early 2000s, we had non-VGT fixed geometry turbochargers. So to make that sound a little more easy, you have one size compressor with one size turbine on one shaft. You may have controlled it with a wastegate, and that was your 7.3 stuff if we're talking power stroke. Okay. Fast forward to the early 2000s, engineers decided, they said, you know, a single turbocharger has a power band within that, you know, 2,000 or 3,000 RPM window that's very small. Turbo lag's our enemy. Turbo lag's the time it takes for us to get optimum boost based on driver demand, which is usually your right foot controlling that. And if we could get that to have that a wider boost band across the whole RPM range, we could make more power and make more people want to drive a diesel pickup because it'll drive more like a gas vehicle. Enter VGT turbocharging. So what VGT turbocharging is we have a turbocharger, generally a single geometry turbocharger, that has vanes inside that we can pitch back and forth to change the effective size of the turbocharger housing so that we get that turbocharger spooling to make optimum boost whenever we need it. Ergo, you're cruising along making 5 pounds of boost and you want to step on it and pass that guy with your trailer. You're gonna have your transmission doesn't have to potentially shift down. Those vanes can simply pitch. We hit optimum boost, we hit optimum torque in the RPM band, and off we go. Whereas a fixed geometry turbocharger would have to spool up to hit that optimum boost before we could do that. I'm gonna show you, this is a 6-liter turbo here. There was a couple different variations on this, but this is that same turbocharger out of the picture. So what we have is we have our exhaust comes in to drive your turbocharger just like normal, and your exhaust exits when it's done doing that. We have a solenoid that goes in here that pitches a pendulum, or a piston, which then pitches a pendulum to physically change these effective vanes. All of that at the time, then that's just for driving of your turbocharger. Your fresh air coming in to your turbine here, or your compressor housing I mean, building up your boost and exiting to go to your intercooler or directly into your intake. What does that look like? Well, again, these are just cores. I know they're dirty, guys, but stay with me. Basically, that's that same turbocharger split. It's easy to see because this was the first generation of VGT turbocharging. So, like I mentioned, we have a solenoid that uses oil pressure, puts oil pressure on one side of another of a piston within here. That piston moves back and forth, turns a pendulum. All again, we have 12 volts running oil, so 12 volt solenoid over oil to run this pendulum, which then runs this unison ring, which, see those vanes moving there, guys? Keeps everything moving correctly. So this would be your small turbo, and this would be your big turbo. The idea then is you have a small turbo, which spool up really quick and have very little lag, but seem to run out of steam at the high RPM, and large turbo, which take a long time to spool up, but man, once they do, we get excellent air volume at the proper boost. We have the best of those within one, and that's what variable geometry turbocharging is. Now we'll talk about the problems in a second that go along with this, because these weren't perfect by any means being first generation, but first we'll jump forward to the next generation of power stroke. Once we got to 2008 in the power stroke world, we jumped to the 6.4 liter engine. Neat thing about the 6.4 in turbocharging was they went to twin turbo. So the idea was this system worked well. How can we take the stress off that turbocharger? Well, we have a normal fixed geometry turbocharger, which then crosses over and feeds a secondary variable geometry turbocharger. The idea is this single fixed turbocharger spools up quick and actually starts, because this is a in series system, not in parallel, starts to spool up this turbocharger. We use VGT running on an electric motor directly into that piston, no oil systems here. And therefore then the secondary turbocharger can spool up, and the two of them working together in series, we can get optimum boost across that RPM band at any given time. And if you've driven a 6.4 in stock form, you know that you get out to pass somebody and that boost is there perfectly every time you need it. These don't downshift, they simply lug and go. And when you tune this twin turbocharger design, there's not a lot of trucks that will compete with it in stock form. You know, Spartan, tuners, and others, you push a couple buttons and you pick up 300 horsepower without even putting any hard parts on. It's not necessarily the best thing for them, but hey, it works. Then we go one step further. This system worked really well, but it was horribly expensive to design in comparison to our single turbocharger because it's 2 turbochargers. In comes the 6.7 liter, again, stick with me on Power Stroke, and they thought, you know, 1 turbocharger with VGT is good, 2 turbochargers is better. How can we make 2 turbochargers into 1 and have VGT? Well, they brought out this engineering feat. This is a single turbocharger running VGT on a solenoid and a wastegate. So we have the variation of your exhaust housing to get exactly where we want it. But then the neat thing was they have 2 air intakes. So we have an air intake that was low speed and an air intake here that's high speed. So what you have is you have a single shaft running a single compressor and then 2 turbine wheels. And they face each other opposite. I'll give you a picture of this here out of the book in a second, guys. But basically, when your RPM effectively is better for the low speed turbine to create that boost pressure coming out of here heading to the engine, or to the intercooler in the engine, that one will bring in the optimum amount of air. And when we hit an RPM band where this one makes more sense because the vanes and the pitch on that turbine is slightly different, this one becomes more effective. So they're all in the same shaft, they're all spinning at the same time. It's just depending on which turbine assembly is going to do the work for you. Again, we still use VGT, which means we still have an exhaust housing that is infinitely variable. That way we can create that correct amount of spool up on that same shaft. Then we also liquid cooled it, which they learned from Duramax things. And we have oil coming up through the pedestal like a 7.3, or so actually down through the pedestal like a 7.3, so that we physically have proper lubrication. Down upsides to this, single turbocharger, a little less expensive to create than your twin turbo design. Excellent spool up, maximum boost exactly when we want it. Efficiency was better, so our fuel economy numbers got better. Downsides, it's a very, very difficult shaft to balance when you're building it like that. So we did see turbocharger failures in the 2011 to 14 design. Now they made a bearing change. It really didn't seem to help a whole lot mid-production. But if this thing gets out of balance and starts shaking a bit, the bearing comes apart and the shaft eventually will break and then the whole turbocharger grenade. And that's what we generally see with them, guys. So we don't see the turbocharger VGT sticking like we did on the 6-liter, but we definitely did see a couple problems with this. 2015, they made some slight changes to this, went back to a single style, got rid of the second air intake, and that's what we're stuck with now with Power Strokes. Now VGTs are great. We have the efficiency of multiple turbos in one. That's why it's called variable geometry turbocharging. Let's talk about downsides for a second. I'm going to give you another turbocharger to show here. Identical turbocharger, again, it's just one I happen to have that's coming apart. So we talked about how oil pressure will push this solenoid back and forth, or push this piston back and forth to run this pendulum. And you saw how easy it was for me to move that other one. That's everything to move that, guys. So you can see how this ring has seized to this housing. Obviously, a 12-volt solenoid pushing oil pressure, that is not going to be able to move that. Now that turbocharger is stuck. Now it might stick at big turbo, it might stick at small turbo. Either way, once that's happened, if we're lucky, we can get this off, we can clean that housing, and there was a technical service bulletin for that, and get that unison ring to move correctly again. It's something we do in all our bulletproof packages. However, sometimes the damage gets too far. Either this area where the pendulum sits wears, the actual pendulum itself can wear, the turbocharger housing can rust so bad you're never going to get it clean so it moves correctly. In the vane areas, these vanes can seize on their pins sometimes. A lot of issues happen, and it's the technician's job to determine whether or not this turbocharger is salvageable or not. You'll notice this turbocharger specifically, if you zoom in there, you see that damage on the compressor, on the turbine, I mean, that damage is caused by high exhaust temperatures, which were probably caused because this turbocharger was stuck for so long and that guy was towing hard. So this is a completely failed turbocharger. It's not worth rebuilding at that time, especially because these turbochargers become much cost effective to buy as a new replacement from a good supplier. So again, there are downsides to VGT if it starts to screw up. Let's talk about our other brands for a couple seconds. I don't have cores to show you on these. Duramax used a fixed geometry turbo similar to our 7.3s in Power Stroke land from 2001 to 2004. That's your LB7s. They realized, just like every other engineer did out in the market, that variable geometry turbocharging was the way of the future. LLY comes in 2004 and a half and carries through. It has a single VGT turbocharger. It's actually, believe it or not, almost identical turbocharger to this, other than the mounting pedestal was different than the 6-liter. But what Duramax did was different and smarter. This little port on top that sits right in this pendulum is the perfect spot, and it's what Garrett designed this turbocharger to have, a turbocharger vane position sensor. 6-liters don't have them. They simply rely on the rest of the sensors, map and MAF, and exhaust pressure to tell the computer if something's wrong. It doesn't work that great until it's way too late. Duramax actually have a position sensor in here that tells the computer where that pendulum is at all times. And if it tells the pendulum to go to a certain spot and it doesn't go there, it will generally pick up that problem before it becomes a big problem, and you can potentially service and save this turbocharger. Hence why we see less turbocharger failures on your LLY and up Duramaxes. Now Duramax has kept that same basic turbocharger design right through till current. It was also liquid cooled where the 6-liter was not, which means we could keep it at optimum temperature, which caused less failures. Great working turbocharger with the Duramax application version of that Garrett. Talk about Cummins for a second. Cummins used a couple different variations of fixed geometry turbochargers through their 1st gen, 2nd gen, and up until your 2007 from 5.9 to 6.7 switch. So all 5.9s come with a fixed geometry turbocharger. They worked really, really well for what they were. Once you jumped to your 6.7 in 2008, you went to a single VGT design. The difference was they learned from the other engineers out in the market and what was available. They went to a similar design to an electric motor running their VGT within their turbocharger, so that every time you cycle that key, you can keep those vanes from seizing up. You simply cycle your vanes like that and we don't see the turbocharger seizing up. Again, like I said, they run an electric motor, there's no oil pressure there, so they seem to have a lot less problems with that turbocharger, and hence they've kept that same turbocharger design from your 2008 really to current. So everybody on the market's using this. We're seeing it in the smaller diesels like the new 2.8 Duramax. We're seeing it across the line. VGT is something that's gonna stay. Having a technician that understands how your VGT is working or supposed to be working on your truck, and making sure that if you do have a problem or you think truck's not working as it should, bring it in, get it checked, and make sure that we can get the system sorted out before we have a major failure like that, because it'll cost you a lot less money, and that's the end goal, guys. So I think we've run another long video. We'll wrap it up for now. Tag your friends so they can see our videos and they can get educated. An educated customer is a happy customer. Follow us on Facebook, follow us on Instagram, guys. For now, at DG's Pro Tech, I'll let you go. Thanks again for watching.